Off with, I'd like to explain what an alcohol is. An alcohol is an organic compound that has an hydroxide group as its main functional group. My objective of this video is for you to be able to draw and name alcohols using the proper IUPAC rules, and for you to be able to accurately predict the products of chemical reactions involving and forming alcohols.
When naming alcohols, you will use the suffix "-ol" in their IUPAC name. So, in the cases of propanol and butanol, they both have the suffix "-ol", their names, and then they also are alcohols. So, in looking at the line diagram below, you can name it by counting the carbon chain. So 1, 2, 3. So this means that the carbon chain is the root of the carbon chain is prop, meaning there is 3 carbons. So now we see that none of them are double bonds or triple bonds. So that would mean their other part of their name is ane. So propane. Now we can also see that there is a hydroxide group next to them, which would cause it to be alcohol. So on the second carbon, so it'd be 2-ol. Now all we need to do is put it together. So prop is the root, so it goes first, then ane, then 2-ol. And we drop the e because we use this suffix "-ol". So when drawing alcohols, there are 2 options. We can either draw the complete structure diagram or the line diagram. In both cases, you have to find the largest carbon chain. So in propanol, the largest carbon chain, you have to draw the largest carbon chain, so which is 3, because this root is prop. So we also see the hydroxyl group at the end of the carbon chain, which is done because there is no number in front of propanol, which signifies that there is a hydroxide group on the first carbon, the carbon chain. So in the line diagram, we show the carbons by showing their bonds. So we see that we're using propanol again. So we can see that there's a carbon bonded to another carbon, and then there's another carbon and this middle carbon connected to another carbon, and the hydroxide connected to that carbon, signified through their lines. So now we see since our root is prop, we have 3 carbons, and since we use the suffix "-ol", it signifies the alcohol, and since there is no number in front of propanol, it is on the first carbon. So now we see 2-butanol, and we will draw this diagram for it. So we see that 2, it's a root. So here we see that the root is, since the root is but, we have a carbon chain of 4. So on the both structure diagram and the line diagram, we see that I did number the largest carbon chain, which is 4. And we also see that there's a hydroxide group on the second carbon, signified by the 2 and "-ol". So there are many different types of reactions that form alcohols. So some that do form alcohols are substitution reaction, elimination reaction, and a hydrolysis of esters reaction. These all have different ways of forming alcohols, but they all end with an alcohol, except for hydrolysis of esters, which form a carboxylic acid as well. So in the case of a substitution reaction, it substitutes a hydrogen with an OH group. With elimination, it adds the OH group, and the hydrolysis of esters breaks the ester into a carboxylic acid and a alcohol. The reactions that involve alcohols are the synthesis of esters, oxidation, elimination, and condensation. So in the case of synthesis of esters, it synthesizes the ester using a carboxylic acid and a alcohol. For oxidation, it takes an alcohol and using a strong or weak oxidation reagent, it forms an aldehyde or a carboxylic acid in this case, or a ketone. Elimination takes an alcohol and forms an alkene, and condensation takes two alcohols and forms a ether. In the case of elimination, it forms a double bond by taking a hydrogen and hydroxide ion out. Thank you for listening to my video, and I hope you can now name and draw alcohols and predict their reactions.